We are going to start now.
Okay.
Okay, let me see this one. Okay, first one. First one, we talk about the dimensions, right? So when we
Mm-hmm.
talk about dimensions, we are referring to the physical quantities. I'm here,
Okay.
this part,
Mm-hmm. Yeah.
thick green color. Now,
Mm.
what is a physical quantity? A physical quantity is something that can be measured. It has units, okay? It has magnitude, that means it has size. So for example, let's say length is a physical quantity. It has
Okay.
magnitude, probably we say 1 meter. So meter is the
Mm-hmm.
unit, one is the size, the quantity that we have. So we want to measure 1 meter, we can use some instruments. So we can use a meter rule or a measuring tape. So dimension is a physical quantity. Now, other than length, okay, so we have this. Other than length, we have mass, time,
Yes. Fine.
and temperature. Now, these are also physical quantities. But
Okay.
these physical quantities that we mention here, they are the base quantities. Now, what
Okay.
is quantity? Right? Base quantity, they are the most basic building block lah, for physical quantities. Now, other quantities, they are called derived quantity. So this derived quantity, they are uh, a combination of several base quantities. Right? So the base quantity,
Hmm.
they are building blocks. Okay, these physical quantities, they are the building blocks. So far, any question?
No, understand.
Understand? So you know,
Yeah.
uh, dimension is about physical
Physical
quantities.
quantity.
Yes, physical quantities, there are two types. One is the base quantity, the building
Quantities.
blocks, and the other one is the derived quantity, which is
Okay.
a
Yeah.
combination of one or more of these base quantities. Now, in
Okay.
your textbook, the symbol that they use to represent mass is capital M.
Yep.
They used to represent the length is capital L and time is capital T. So this is what they use in the textbook, right? Okay, right. Then now in mechanics, we are mostly involved with this mass, length, and time. Probably
Okay.
later on you may want to include temperature, right? But in physics, most of it is not physics. In mechanics, the only these three: mass,
Okay.
length, and time. Okay, right. So now these quantities that I've listed here in this table here,
Mm-hmm.
area, volume, velocity, and so on. So they are the usual derived quantities that we encounter in our daily life. Probably
Okay.
when you get involved in sports, right? So this acceleration probably and velocity probably when you are running, you get to you can have this velocity, acceleration, and so on. Oh, in let's say our throw, javelin, shot put, and things like that, probably we have
Mm-hmm.
this momentum, right? Momentum, right? And so on, right? So we'll talk about this later, but if you have come across this type, it is better for you to
Yeah. Okay.
remember the formula for these derived quantities, the formula and their units, right? So it
Mm-hmm.
will be easier later on lah, when we discuss. But so for the time being, if you have come across this, then it's very good. If you have not come across this, then you just go through these physical quantities here.
Okay.
Okay, any question?
No.
No,
All good.
no. So we continue, right?
Yep.
Oh, we continue. So let me clear all these marks here. Okay. Then I use the mouse. Okay, we carry on. Now, in your textbook, these dimensions, the physical quantities that I've mentioned earlier,
Mm-hmm.
length, time, and mass,
Time and math.
they are used to check the formulas. In physics, we have a lot of formulas involving these derived quantities, you know, like acceleration, velocity, right, and so on. In physics, we have a lot of formulas like this. So one of the use of this dimension is to check this formula. Oh,
Okay.
if there's a formula there, that means there's an equal sign, right? So we check whether the dimension on the left hand side is the same as the dimension on the left hand side or not. Or
Okay.
I will elaborate. I will elaborate. You don't worry. So generally, it's like this. We have an equation. So each quantity on the left hand side, we check the dimension. The quantities on the left hand side, we check the dimensions and see whether they are consistent or not. Whether the dimensions are consistent or not. If consistent, then the formula is correct. If it is not, then the formula is wrong. Or sometimes we know the relationship, but we don't know the exact relationship. So we use this to find out the relationship between these physical quantities or the
Okay.
variables involved, right? So this is part of the textbook. Let me explain in detail, right? Now, one of the physical quantities that or the dimension that is involved is uh, length. Okay,
This. Okay.
the physical quantity is the distance. Distance. The symbol that we use for distance in the textbook is x.
X.
The dimension is length, and we represent
Okay.
length using capital L.
So,
Right. Then another one mentioned here is the time. I use a tick there to show. Okay,
mm-hmm.
okay, this one. Okay. Now, another physical quantity or dimension we use is time. The symbol for time is small t, okay,
Okay.
the symbol. And the dimension, of course, is time. And the letter they use to represent it is capital T. Next one, we have velocity. Okay, the symbol for velocity is V. The formula for velocity is the distance divided by time. This is the formula.
Okay.
Um, let's say if you are not familiar with the formula, you just take it as, oh, this is the relationship between velocity, distance, and time. So this is the relationship. It comes to you
Okay.
in the form of a formula. Now, if you want to talk about the dimension of this velocity, the dimension of velocity, since it is the distance divided by time, the dimension will be length divided by time, L
Okay.
over T. Is this okay?
Yep. Yep. So
Yeah.
formula will be okay.
Okay, right. Then next we go on to acceleration. The symbol for acceleration is A. The symbol used in this paragraph here, the symbol is A, and the formula for acceleration is the rate of change of velocity. But don't
Okay.
worry about this rate of change of velocity. Let's say it is velocity divided by time. Okay,
Yep.
velocity divided by time. So when we want to find out what is the dimension of acceleration, so we look into this velocity. Velocity is actually length divided by time, then divided by the time again. Right? V is actually
Okay.
L over T, and T is the capital T here. So when we simplify further, the L is at the top, then this 2T is at the bottom. So it becomes L
E square.
over T squared. Now, sometimes if you want to write in indices, right, or in index form, it will be L T to the power of negative 2.
Two. Two. Okay.
So far, okay or not?
Yep.
from this part, the dimension is LT, then divide by T again.
Mm-hmm.
Okay or not?
Yep.
Okay. So if L divided by T, then divide by T again, that means it's L divided by T squared. Now in index form, it is LT to the power of -2. Right. Now we look at one example